Section 3.3 is on rate of change and slope. Rate of change is defined as the change in y divided by the change in x. Let's take a look at a couple examples. Here it says find each rate of change. So what we'd like to do is look at the y values first and figure out how much y changes each time we move from one value to the next. Okay, so when we move from -6 to 2, we're adding 8. When we're moving from 2 to 10, we're adding 8. 10 to 18, we're adding 8. And from 18 to 26, we're adding 8. So the change in my y is going to be 8, a positive 8. Now let's figure out what our change in x is. When I move from 3 to 5, I'm adding 2. 5 to 7, I'm adding 2. 7 to 9, adding 2. And 9 to 12, I'm adding 2. So my change in x is a positive 2. So positive 2 divided by, or positive 8 divided by positive 2 means my rate of change is 4. Or sometimes it's written as 4/1. Here's a graph, and we need to figure out what is the rate of change in this one. So let's see what happens as we go from this point here to that point there. My change in y, as I move from this point on the y-axis to this point out here in the first quadrant, so from here to here, that's a change in 1, 2, 3, 4. That's a positive change of positive 4. And as I go from this point to that point, my change in the x direction is going to be this right here, and that's a positive 3. So my rate of change is going to be a positive 4 over a positive 3, or leave it as a fraction, 4/3. And whenever we're talking about rate of change, or as we'll see in a minute, slope, we always leave it as an improper fraction. We don't write it as a mixed number. If the rate of change is constant between all pairs of points, then we can say the function is linear. So here's a couple examples. We need to determine whether each function is linear. So do I have a constant rate of change in my y's? And it sure looks like that in each time I'm adding 4. So that's good. So I have a constant change in my y's. Now do I have the same thing in my x's? As I go from -3 to -2, I'm adding 1. As I go from -2 to -1, I'm adding 1. And as I go from -1 to 1, I'm adding 2. So no, this function is not linear because it does not have a constant rate of change. Not a constant rate of change. Because notice, even though my y's changed at the same amount, my x's did not. Let's take a look at our second table here. So let's check our y's first. When I go from -4 to -4 to 1, I'm adding 5. 1 to 6, I'm adding 5. 6 to 11, I'm adding 5. And from 11 to 16, I'm adding 5. So my change in my y's is constant. How about my change in x's? When I go from 12 to 9, I'm subtracting 3. Same thing when I go from 9 to 6, from 6 to 3, and from 3 to 0. So I have a constant change in my x's, which is a positive 5, and a constant change in my y's, which is a -3. So my rate of change would be a -5/3, and so yes, this is linear. And it's linear because it has a constant rate of change, -5/3. The slope of a line is the ratio of the change in the y-coordinates, that is the rise, to the change in the x-coordinates, the run. Some of you may have heard of slope referred to as rise over run. And it's basically the slope is the rate of change of a line. So here's the official definition. The slope m of a line through the points x1, y1, and x2, y2 is m equals y2 minus y1 over x2 minus x1. If you haven't seen this notation before, those little 1's down there and those little 2's down there are subscripts. They're not squared, it's just the name of 2 points. First point is x1, y1, Second point is x2, y2. So basically, to find the slope, you're going to subtract your y's and put that on top, and then you're going to subtract your x's in the same order and put that on the bottom. Let's take a look at a couple examples here. Find the slope of the line through each pair of points. So if you're new to this, or if you think you might get a little confused, it's okay to go ahead and label these x1, y1 and x2, y2. And then recall that our equation is that the slope is equal to y2 minus y1 over x2 minus x1. Probably a good idea if you memorize that. So my y2 is 10, my y1 is 2, so I subtract those. My x2 is negative 2, and my x1 is a negative 4, so that's going to be minus a negative 4. And remember, when you're subtracting a negative, it's the same as adding a positive. So that's going to give me 8 over 2. Reduce that to 4. So the slope through those 2 points is 4. Let's take a look at our next example here. Again, if you want to label these x1, y1, x2, y2, and then my slope is y2 minus y1, so 11 minus 3, over x2 minus x1, negative 1 minus 4, or 8 over negative 5, and I just kind of prefer to put the negative out front, so negative 8 over 5. And let's take a look at two more examples that are kind of special cases. So we have x1, y1, x2, y2. So my slope is going to be y2 minus y1, 7 minus 7, over negative 2 minus 6, or 0 over negative 8, which is equal to 0. In this case, the slope of the line is 0, and any line that has a slope of 0 is going to be a horizontal line. That's another good thing to memorize. And then let's take a look at our fourth example here. x1, y1, x2, y2. And let's go ahead and subtract those points. So slope is negative 6 minus 2 over negative 3 minus a negative 3, and remember, minus a negative is plus a positive, so that gives me negative 8 over 0. And recall that you cannot divide by 0, so the slope of this line is undefined. And that's the word I'd like you to use. You may have heard no slope in the past. I prefer undefined. And that equation of that line, what that line is going to look like is that's going to be a vertical line. Its slope is undefined. So here's a little chart to kind of describe some of the slopes. If a line is basically going uphill as you read from left to right, it has a positive slope, that is m is greater than 0. It's a positive number. If it's going downhill, it has a negative slope, that is m is less than 0. If it's a horizontal line, it has a slope of 0, that is m equals 0. If it is a vertical line, it has an undefined slope. M is undefined. We don't even use a number here, we just write the word undefined. So please memorize these. And our last example here is what I call an R problem. It says find the value of R so that the line through the point negative 2, 6 and R negative 4 has a slope of negative 5. So in other words, I know what x1 and y1 are, but I don't know what x2 is, I know what y2 is, and I know that my slope is negative 5. So the starting point for this is going to be our equation, or a little formula for finding the slope of a line. And notice that I know what m is, I know what y2 is, I know what y1 is, I don't know what x2 is, that's my r, and I do know what x1 is. So I'm just going to plug in those values. So my slope is negative 5, and I'm going to write that as negative 5 over 1. y2 is negative 4, y1 is 6, x2 is what I don't know, that's r, and x1 is a negative 2, so minus a negative 2. So let's go ahead and clean that up a little bit. Please leave that as negative 5 over 1, as you'll see in a minute. Negative 4 minus 6 is a negative 10, and that's going to give me an r plus 2. So basically what I have is an equation here that I need to solve for r. And notice that it's a proportion, so I'm going to solve it by using cross products. So those guys, are going to be equal to each other. So that's going to give me 1 times negative 10, and that equals negative 5 times r plus 2. So negative 10 equals, let's go ahead and distribute, negative 5r minus 10. Okay, and adding 10 to both sides gives me 0 equals negative 5r. And dividing both sides by negative 5, I get that r equals 0. So when my x-coordinate here is 0, then this line has a slope of 5. So in this section we looked at what rate of change is, that is basically the change in y divided by the change in x. We've figured out how to find that given a table or a graph. Then we looked at slope and we learned this equation here, and figured out how to find the slope of a line and learned what a positive slope, a negative slope, a slope of 0, and an undefined slope are.